see. Greetings and welcome, friends. Today we're talking about systems of conics. That's right, we're like morphing together two of the concepts you've previously learned, systems of equations and conic sections. So instead of finding the intersection between, say, two lines, which you guys knew could occur no times, one time, or infinitely many times, Kirsten, please follow along. You might recall that happened. Today we're going to talk about conic sections, and there's actually all sorts of interesting things that can occur. So let's say I've got two conics. Let's say I have an ellipse and a circle. How many times could an ellipse and a circle intersect? You guys think? Well, I could have it hit 4 times. This looks like Saturn almost.
6.
Could I have it hit twice? Yeah, if it was like that or something, or this.
Couldn't you use it
Oh, yeah, like if it was somehow tangent, like some weird eyeball, like yeah, if I somehow drew that correctly. And actually, the way I drew it, it actually hit 3 times. So if it was 1 tangent point and 2 where it crosses. You also could have had the ellipse inside the circle, right? Something like that. 2 intersections there. And then 4 intersections, 1 intersection. Could I have 1?
Yeah.
Yeah, that would be something like this, where it hits once, or even like this, it could hit once.
Oh, looks like keep drawing. It looks like Yep. A cat. I'm seeing a cat.
Yeah, me too also.
Okay.
Or a baguette.
So anyways, so conics can have actually multiple kinds of intersections. So actually, let me bring that back. So between an ellipse and a circle, I could have had 1, I could have had 2 intersections, I could have had 3, I could have had 4 intersections. Could I have had 0 intersections?
No. Never.
Well, yeah, they're on the same graph and they're just not touching at all.
Yeah. Like our rules for Jacob and Hank, like stay away from each other, stop messing, right? Just keep them away, and no one gets their cell phone taken for, I don't know, like kidnapped.
I guess that rules apply to me.
That would be nice.
So
let's take a look at this. How about between a parabola? That's good enough of a parabola, something like that. I'm just going for general concept here. How about a parabola and an ellipse? How many? Could I have 0 intersections? Yeah, that would just be like that, right? Could I have 1 intersection? Right, even if it was like that, or if somehow I had it tangent at a point, that'd be crazy, but it's doable. Could I have 2 intersections? Yeah, like that, or if somehow I hit it tangent exactly twice. Could I have 3 intersections?
Yes. The tangent and 1 tangent.
Yeah, 1 tangent. What about like this? Even that's a crazy one.
Could you pull off 4?
And yeah, 4, I think you guys agree. Right, I could have 4. So in this case, I could also have 0, 0, 1, 2, 3, and 4. So I just want to get you guys thinking about the fact that we're going to have multiple intersections here. You can actually deal with these somewhat graphically if we wanted to. But we're going to do most of our work algebraically today. In fact, we're only going to do 2 examples today, which shouldn't be too bad. In the first one, we only actually will have 1 conic, oddly enough. Oh, that was a loud snapshot. Bam. So,
She stole Jacob's phone.
anyways.
That would be so good for like little out of all time.
So let's solve this system algebraically. So I've got, it looks like something in general form here, and then it looks like something that's in some unusual form right there. That's actually, looks almost like standard form of the equation of a line, oddly enough. So yeah, so this is actually the equation of a line. And does anyone know what the top equation is an equation of? Well, let's see. It's got 2 squared terms, so it can't be a parabola.
The thing that says the
Hyperbola would have opposite signs for my 2 squared terms. Yeah, that's general form of, but
Yeah, general form.
this is general form of what curve, what type of conic?
Ellipse.
It's an ellipse. Well done. That's what our side quest was about last night too, right?
Yep. That's
Yeah.
why I actually knew it.
Yeah. So the reason he knew it was an ellipse was because there was two square terms, and their coefficients were not the same. If they were exactly the same, that'd be a circle. And the fact that they were still the same sign indicated it was elliptical. If they have different signs, then it's hyperbolic. So our general strat. So actually, before I even get there, I've got an ellipse and a line. How many answers do I expect from this? So if I've got an ellipse, say something like this, and a line, could I have one answer?
Yes.
Yeah, if it was like somehow like hitting tangent, pretend that hit there. Could I have two answers?
Yeah.
Yeah. Could I have three answers? No, I can't. So I'm expecting. Could I have zero answers? Yeah, if they're just like nowhere near each other, right? Sort of thing like that. So I'm expecting that sort of thing. I'm actually going to solve this by substitution in this case. And notice that I actually could solve for either x or y. I'm going to solve for the equation of the line. And if I solve for x, I will have an equation written all in terms of y's, or a constant, right, if I get these to the other side. And what I'm going to do is then plug in for x and rewrite that all in terms of y's. So let's do that. So for x minus 3y minus 3 equals 0, to solve that for x, add 3y to both sides and add 3 to both sides. And I'll get x equals 3y plus 3. And this is a true statement. And since those are equal to each other, just like Indiana Jones would do with a golden idol and a bag of sand, we're going to substitute them into the other equation. And there's only one x in this equation, so I'm going to replace said portion, right, with this expression, this revised equation, if you would. And what's that going to do? That's going to give me an equation all in terms of y's, which is great. So I'm going to have 3 times 3y plus 3, all squared, plus 2y squared minus 54y minus 143 equals 0. And this equation is all in terms of y. It looks like it'll likely end up being a quadratic once I simplify it. So this could give me as many as 2 answers, which is what I'd expected as a possibility when I was drawing my little like could have had 2 answers there, right? So let's do this. Guys, you might need to expand this out. Do you remember the pattern for that?
Don't you just have to put it at the
Yeah, so I'm going to use this pattern where A is the 3y and B is the 3, and just plug it in this. It would be super illegal if you tried to distribute a square over addition. We would cry about that all night. You also could have written 3y plus 3 times 3y plus 3 and foiled it or double distributed, blah, blah, blah. So 3 times, still on the outside, right? 3y all squared. And I'm going to write this whole step out, even though maybe you could do some of the simplification in your head. 2 times ab, or 2 times 3y, 3, plus b squared is 3 squared. Yikes. And then plus the 2y squared minus 54y. All that stuff's the same, unchanged right now. Right. So let's simplify yet a little more. Yeah, it takes a little bit of work for sure. Let's square this. So this is 9y squared plus 6 times 3 is 18y plus 9 plus the rest. Here on Gilligan's Isle. Anyone know? Let's see, 27y squared plus 3 times 18, 30 plus 24, 54y. Oh, what? No, they didn't. What? No, they didn't.
They did.
They done doed it, friends. This problem is conveniently super friendly.
Just like me. Yo, conveniently super friendly.
It's accurate statement.
Thanks, Mr. Waddy.
So let's go through and keep simplifying, combine some like terms. It looks like the 27y squared and the 2y squared, those are friends. You might have realized 54y and negative 54y. Those guys, whew, yikes. Yikes, those guys just cancel each other out. And then these guys are like terms as well. So 27y squareds plus 2y squareds is 20 nueve y squareds. Let's see, negative 143 plus 27. Let's see, it's going to be negative, I know that, because the more influential one. 143 minus 20 would have been 123 minus 7 would have been 116, is that right? All right, I got some backing on that. So to solve this, I actually don't have to factor it now. I could, because there's no middle term, the y's canceled out. So I can actually just solve this by bringing this to the other side, isolating the y squared, and then rooting is what I'll do. It sounds like a fair approach to this. 29y squared equals 116. Divide both sides by 29. You know, it would be wonderful if that somehow went in there. Does it? Anybody?
I know.
Yeah.
116.
No way. What?
It's like 0.
It's like 4.
I did 16.
So now to solve, I root both sides. Plus or minus. Don't forget it. So I get y equals plus or minus the square root of 4 is 2. Now, what I would like to point out is this is telling me that I have 2 possible y values for a solution here, suggesting that there was 2 possible answers. Well, I found only the y coordinates. I need the x coordinates.
Oh. Yeah, you better only give us like 2
Hey,
problems.
hey, don't you worry. So let's plug this in for this equation, x equals 3y plus 3.
I feel like we've done this
And
already.
yeah, we've done a lot of stuff exactly like this, so it's not that bad. X equals 3 times positive 2 plus 3, or x equals 3 times negative 2 plus 3. There's 2 possible things for y, so I have to actually plug in both of them to find their corresponding x coordinates. So x equals 6 plus 3, or x equals 9. And over here, x equals negative 6 plus 3, or x equals negative 3. So my solutions are the points 9, 2, or negative 3, negative 2. I have to make sure I pair up the right ones with the right ones here. So those are my solutions, and fortunately that verifies with what I'd anticipated from my little pre-done problem here. And I'm actually going to show you guys a graphical representation of this.
Wait, can you go up a little bit?
Yeah, I can do that. So yeah, I just plugged the negative 2 and the positive 2 in, solved, right, or simplified actually. It was just arithmetic from that point on. And then I got my 2 equations. So I don't want you to graph this necessarily, unless you just draw like a super basic sketch. But notice when I graph this ellipse exactly and the line exactly, notice where my intersections occur. This one's at 9, 2, and this one is at negative 3, negative 2. So I do in fact have a graphical representation of this, and I just want to point out that that plus or minus that came from the square root, or if I'd ended up having to solve a quadratic, that's often where your 2 answers can come from, that sort of situation. So that's the intersection between a line and a conic section. Let's do our last example.
Is it going to be like a full page of paper?
Probably about a page, and it's nice to sometimes give yourself some space to work with. Right, it's a little less. So, well, don't worry about it right now. Let's focus on this.
Oh!
So, solve the system algebraically. here I've got my two equations. Write this down because we're moving on, friends. So let's see actually if you guys can determine what types of conics these are. So I've got two conics, and I believe conics can have as many as 4 intersections. Well, let's verify what they are. The top conic in general form, what kind of conic do you think that is? It's an ellipse. There's 2 squared terms. They're positive, same sign, and they have different coefficients, so that's elliptical. And what's the second one? Two squared terms, same signs, and same leading coefficients. So it's a special case of ellipse called a circle. Circle, right? So now this is actually going to be a little bit trickier. Well, let me explain kind of the logic, I guess, first. Now, this equation has x and y. This equation has x and y. If I solved, say, for this x, I'd have an expression in terms of y squareds and x squareds, and that would be gross. Yeah. And then if I even plugged it back in for x, it would have still reintroduced this other x squared term somehow in that, and it wouldn't have actually gotten rid of one of my variables. So I have to get rid of one of the variables. But notice, I've got x squareds and a linear number of x's. If I could get rid of this y squared here somehow, that would be nice. So what I'm actually going to do is linear elimination, or linear combination, the elimination method. And if I could eliminate the y's between these two, I'd actually have, because I could do that, it would still have an x squared, and I'm fine with that, and it would just have an x there. So I'm going to eliminate the y's because I had more x's present, is kind of my logic to doing that. So equation 2, what I'm going to do is multiply it by something that's going to give me opposite coefficients for the y squared terms. So what would I have to multiply this by?
-25.
You got it, dude. So actually, I'll write that in yellow. YOLO. Multiply that equation through by -25. So I'll have -25x squared minus 25y squared plus 50x equals 25 times 15. I'll just trust a calculator on this one. It's -375 there. So, and now what I'm going to do is add that to equation 1, and that will eliminate my y squareds, leaving me an equation only in terms of x's. Okay, so I'll rewrite this equation down here, although you wouldn't have to because it's already written right up above it. Equals 225. So I've got all my like terms lined up and such. And so yeah, we can do that. So let's add these. So 9x squared and -25x squared, I believe, is that -16x squared? Yep. The 25y squareds, those cancel out. Plus 50x by the looks of it. Equals, and 375 and 225 have a difference of 150, and it's staying a negative. So notice now I've got a quadratic equation. That's lovely, lovely, lovely. And I think we're going to end up solving this using the quadratic formula in a second here. Let's divide everything through. I think everything here is divisible by 2, just to get smaller numbers. And better yet, because I like to have a positive square term, I'm just going to divide by -2's. So I'll have, this would be 8x squared minus 25x. And then the 150 divided by 2, or -150 divided by -2 is going to +75. But before you write that down, I think you guys agree that this is a quadratic, so I should probably pull this 75 to the other side. So I'm going to just subtract 75 and then set it equal to 0. right? So now I've got a quadratic. We could solve by completing the square, solve by factoring if it was factorable. This might be, I don't
It's not. Because
yeah, it looks like it's kind of ugly. I'm guessing it isn't. Let's solve this by quadratic formula. That'll probably be our best bet. So a is equal to 8, b is equal to negative 25. It's nice that I got smaller numbers there. C is equal to negative 75. Quadratic formula, in case you're not recalling right now, is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Bam. So let's plug in some nombres, and I'm just going to simplify this. Now the fact that I have plus or minus here showing up, that tells me immediately I have at least 2 answers. If I'm going to have 2 separate x coordinates, that means I have at least 2 answers. I mean, it's also possible I could have a pair of y coordinates that are different as well. So,
This is just one of the ways you can solve it, right?
yeah, you could have also solved by completing the square, but that would have been really gross fraction work. This is the easiest solution right here, I think. So x equals, that'd be positive 25 plus or minus the square root of negative 25 all squared, or positive 25 squared if you wanted to simplify that right away, minus 4 times 8 times a negative 75z's all over 2 times 8. And maybe you've programmed this in a graphing calculator of yours or something at some point, and you can just plug A, B, and C in. That's quite nice being able to do that at this stage in the game. I mean, considering quadratic formula, that's like math 1 or math 3 stuff. We know what's up. So let's see, 25 plus or minus the square root of 25 squared. And that's plus 4 times 8 times 75. I got 3025 all over 16. Guys, that might be a perfect square. It is. No way, friends.
Are they going to be like this on the homework?
Yeah, well, I think most of them are friendly. You'll actually even be able to use some decimals if they come out super crazy, though, on the homework. 25 plus or minus 55 over 16. So let's break this up into the 2 possible situations. 25 plus 55 is 80 divided by 16 is 5. So there's one of my possibilities. Or x equals 25 minus 55 is negative 30 divided by 16. And that can reduce a little bit, but not to a whole number, sadly. So that's going to be 15 eighths, I believe. Or that's, let's see, 15 eighths, 1.875, if you want to think of it that way. So I've got 2 possible x values. What do I do with this now? I still got to find y. Plug it in. It looks like this one's easier to work with, right? Or the top equation. Or no. No, actually the second equation seems like the easiest. Let's plug it into that. Right? Am I right? Am I right? I'm right. So I'm going to plug in 5 once, and I'm going to plug in this guy once. All right? So that's what's going on here. So I'm going to have to evaluate it twice there. So it was x squared plus y squared minus 2x equals 15. Yeah, that's probably a little easier. So plug in the first one. X squared is 5 squared plus y squared is yet to be unknown. It's yet to be discovered by us. Minus 2 times 5 equals 15. And then just crank through, solve for y. You guys are master solvers these days, though. Y squared equals, let's see, 15 plus 10. Oh, wait a minute. I think I get y squared equals 0 on this. And then root, a plus or minus of 0 is 0 still. Craziness. So y equals 0. So that means one of my solutions is 5, 0. Because this is the y value I got when I plugged the 5 in. So I have to make sure I pair up the... Yeah, I have to pair up the right y with the right x. I can't just like mix and match them later. And now let's plug in the, what do you guys think?
Are we gonna have to graph
Should I?
it too?
No, but I'm going to show you a graph just to help you understand what happened here.
And then-
Let's plug in, yeah, I guess I'll plug in the fraction and brute force it. So negative 15/8 squared plus y squared minus 2 times negative 15/8 equals 15. And I mean, now it's a gross fraction problem, but it's still doable. 225/64 plus y squared plus the double negative. That's going to be 15/4 equals 15.
I have a question.
What's up? Yeah.
Why didn't we just plug in the decimal? Would that have been-
You could have, but this is going to possibly give me a more exact answer that I'd understand, which it depends on what you're going for. Like if you're, working at, what is it, GS Precision or something like that, they probably are cool with decimals there, and that would be fine, if your name's Brian and you're designing airplane parts or something, I could see that.
You find out that group is
It's a little shout out there.
right next. Wait, right, this one?
Yeah, it's good stuff. Drumming up some business.
Yeah.
So y squared equals, let's see, I'm going to need to find some common denominators here. I'm just going to crank through this real quick for you guys. If you need some fraction help, go check out my man Con. Let's see, I'd have to multiply this by 64/64. This I'd have to multiply by 16/16. I'm going to get something gross here, though. It's fine, though. 15 times 64 is 960, minus 15 times 16, and minus 225. I get 495 over 64 when I'm all said and done. All right, so you might have gotten the decimal.
That part, though, we could just do the same exact. That's just a bigger.
Yeah. And then root both sides. Y equals plus or minus square root of 495. I'm pretty sure that's not going to work out for us. But the square root of 64 does, actually, let me just tell you the whole thing. 495 over 64 and square root it. I get 2.78. 1, we'll call it. Which means my solutions were, what was the decimal? Negative 1.875. Comma 2.7811 and negative 1.875 comma negative 2.7811. All right, so it looks like I have 3 total answers here
Why is there 3 total?
because the intersection between a circle and ellipse could have had 3 if
Oh,
one of them
because
was
it would be
tangent.
given.
Yeah. So let me show you a graph of what this looks like. It looks like some sort of cool spaceship thing almost. So this is what the graph of it looked like.
I'm not seeing a spaceship.
Okay, I don't know. That's what I was seeing. So here's the 5, 0 solution, right? And then these two, notice their symmetric nature. They both had the same negative 1.875 x coordinate there. And then their y coordinates are also somewhat symmetric over the x-axis in this case. But that was this point, and this point was the negative 1 there. So so that's what we just solved algebraically. But that's the idea. I mean, you just try to deal with the equations. You try to eliminate variables, solve for one of them. Oftentimes with these, you're going to get some plus or minus solutions, or you're going to get multiple values to plug back in when all is said and done. So just be aware of that, and it's not too crazy. It's just merging 2 concepts you've already seen. Bye-bye, friends.